Hi boys and girls, today we will model lesson 24 problem set, and I will get my paper ready and let's read section 1, direction number 1, and today we'll do things a little bit differently. If I could just get you guys to pause the video after I do the example in each section, and then you finish that section of the problem set and then unpause it for the next section of problem set. So here we go. Rename each fraction as a mixed number by decomposing it into two parts as shown below. So we will rename it as a mixed number. Then we have to decompose it into two different parts, which is the equation part and the number line, and we want to model it. Here are your two parts that we're decomposing the improper fraction, and the modeling is a number line and a number bond. So the two parts comes here, the number line and number bond is here. Here we go. We want to identify our unit fraction, which is 3. So our equal parts today will be thirds. That's why the number line is divided into 3 parts. And they have taken 11 thirds and they have decomposed it into 9 thirds and 2 thirds. So they've got 9 plus 2 giving you 11, and your denominator staying the same. The number line, of course, is divided into 3 equal parts at each whole. And if you will count with me here, we will count 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where the 9 thirds is coming from. And then to get to 11, we only need 1, 2 more thirds to get us to 11. So we have broken it down and decomposed it into 2 parts, a 9 and a 2-parter, and 9 plus 2 gives us 11. And how did we end up with 11 thirds? We ended up with 1 whole for our mixed number, 2 wholes, 3 wholes, and then just that extra 2 thirds gives us 3 and 2 thirds. Our first one ended here, our second one ended here at 3 wholes and an extra 2 thirds. Let's do part B together, and then I will ask you to pause and you can do C and D by yourself. 12 fifths decomposed. Let's identify our unit fraction as fifths, and let's go ahead and decompose that into 10 fifths and 2 fifths. The 10 and the 2 coming together to make 12. And then our number line will need to be extended. And to get to the 12 that we need to get to, our wholes need to be divided into 5 parts. So 1 whole would only get us 5 fifths. A second whole would get us 10 fifths. And then our third whole, why do we need an extra whole in this? Why? Because if we stopped here at 10 fifths, we still need to go that extra 2 fifths. So if I am visually showing 1, 2, 3, 4 cuts, gets me 5 pieces. 1, 2, 3, 4 cuts gets me 5 pieces. And 1, 2, 3, 4 cuts again gets me my unit fraction 5 pieces. Now let's go ahead and do our counting jumps. We want to count 10. 1, 2, 3, 4, 5, that's 5 fifths, 6, 7, 8, 9, and 10. That gets us to 10 fifths. That got us to 5 fifths. So we're at 2 wholes, but we need to go 2 more fifths here. That becomes our 10 fifths. And 2 more jumps, 1, 2, gets us our extra 2 fifths. Now we have 10 fifths plus 2 fifths equals, everybody, 1 whole, 2 wholes, plus the extra 2 fifths, becoming 2 wholes and 2/5. And if you will pause your video now, you can complete C and D. All right, boys and girls, we are ready for number 2. Convert each fraction to a mixed number. Show your work as in the example and model with a number line. So we are converting to a mixed number, and we're also using a number line along with the equation. And we're going to do something a little bit different than what Eureka did, but I'll show you that in a little bit. So we're starting with 11/3, identifying our unit fraction here. 11/3, as you can see on the number line, we have our 0, 1 whole, 2 wholes, 3 wholes, and 4 wholes. Each whole is divided into thirds, 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 and thirds, but we have 11 of those thirds. So as you can see, I do not, watch what I'm doing here. I do not like the way that they did that. So I am going to call this, let's look at the number line. It takes us how many jumps of 3 to get to our 9? 3 jumps, another 3 jumps, and another 3 jumps. And why am I choosing 3? Because each whole is being jumped by 3. So we've got 3, 6, 9. That gets us 3 wholes, and that gets us to 9. 2 more thirds gets us to the 11. So we have essentially 3 times 3/3. And that has to be in parentheses before we add that extra 2/3. Again, 3 times 1, this is times 1, this is times 2, this is times 3. That's where 3 times 3 is coming from. We want to do that first and then add our extra 2/3 for the mixed number total of 3 and 2/3. Go ahead and push pause so you can do B and C. All right, last but not least today, we are going to convert each fraction to a mixed number, and as you can see, we will not be using a number line. We have our unit fraction we want to be identified in our head. Each whole will be divided into 4 parts. How many wholes will we need to get our 9/4 there? What we have essentially is 9/4 broken down into 2 wholes. 1 whole would be 4/4. 2 wholes would be 8/4. So we want to do 2 times 4/4. Again, 4/4 is just 1 whole. Each time you do a 4/4, you are stopping on the number line at 1 whole. So 2 times 4/4, again, you have to put that in parentheses first. 2 times 4/4 gets us our 8/4, and that means we only need 1 more fourth to bring us back to our 9/4. So 2 times 4/4 is really 2 wholes. Plus the extra 1/4 gets us a grand total of the mixed number 2 and 1/4. Now, go ahead and pause and finish that section.